Good evening, ladies and gentlemen. Today we're going to look at time series data. Now, this is just a brief overview to do with some terminology of time series data as well as introducing what it actually is, and then the next three videos go through specific processes you need to know that are associated with it. So, time series data is a special type of bivariate data where the explanatory variable is time. Now, you've seen these graphs all the time. Get it? So, for example, on the right here, we have XJO, which is the Australian Stock Exchange, against time. 07, 08, it crashed a bit, and we've been recovering since, etc. On the left is a particular favourite of mine, shows the CO2 emissions on the left-hand axis, and the temperature over the last 450,000 years, largely taken from ice samples going back that old. And we can see that temperature-wise, this is where we are now. Yeah, no big deal, because we've been here before. And what we should notice is that every time in the past, when carbon dioxide levels have risen, the temperature has risen almost at the same time or shortly after. So what happened to make it rise here? You'd have to go back and look it up. Volcanic eruptions, that type of thing. However, we can see that it's never really risen that high in parts per million. Today we're here, and in 20 years, 30 years, we're predicted to be here. The question is then, what happens to the temperature? So time series data will tell a story over time. Now, features of time series data. There are some specific terminology you need to know here. Firstly, a trend. A trend is the tendency of values to either increase or decrease over a long period of time, generally greater than a year. So if you look at Combank's credit, its share price, if you bought it at $6, you would be quite happy now, because now it is worth 85, which is, pretty impressive. It has gone up over time, and there is a generally increasing trend. Does this mean it goes up every year all the time? No. It has ups and downs. There are random fluctuations throughout the entire thing, but in general it has increased. Alright, so here there are several trends. There is an increasing, decreasing, and then a slowly decreasing. So sharply increasing, sharply decreasing, slowly decreasing. So I know I'm going quickly, but we don't want to take too long. Alright, cycles. Cycles are periodic movements in time with a period of greater than 1 year. So the number of sunspots on the sun, clearly, over the years has cycled quite impressively and quite regularly. Note that each one of these peaks is separated by more than a year. Each one of these troughs is separated by more than a year, so we'd call it a cycle. When the cycles happen within a year, it's called seasonality. So, for example, ice cream sales are seasonal. They go up every summer, down every winter. And that cycle, or that will repeat itself within a year. If it repeats itself within a year, then it's called seasonality. And generally, they are calendar related. So they'll go by the month, by the season of the year, or by the week. For example, alcohol sales will typically rise on the weekend. And just out of interest, you can see some data from our lake. BGA's blue-green algae biovolume. You can see that about every February-March, it peaks. February-March peaks, February-March, it peaks. Okay, that one was unusual, that one was rather unusual, but back here, February-March, it peaks. And so does water temperature, rises and falls each year. You can imagine here, the years going up and down, the temperature is rising and falling. Each of these little lines are temperature measures taken at different places. pH and rainfall, you can imagine the rainfall rising and falling. These are sort of real-life time series charts taken by the council from our lake. Alright. Sometimes this seasonality and a trend, so it is possible to have more than one feature appear in a time series data chart. For example, here, this goes, that is 1 year, and we can see it dip around June, dip around June, dip around June. However, over a longer period of time, we can see that on average we're increasing. So there is seasonality present and an increasing trend. Alright, a structural change is when there is a sudden change in an established pattern. We're there, now here. So for example, electricity use might drop suddenly if there was a sudden increase in price. in general, if you increase the price on something, its usage drops. So at this point here, well, that was meant to be vertical, the government could have introduced a tax. We would expect to see a structural change. An outlier is an individual value that clearly stands out from the rest. I've written 9 of 11 there to remind me. An example of this would be the amount of people in the air at any one time. So, time here, people flying around the world at any one time has generally increased over time, except for the days after 9/11 when almost everyone in everyone in America was grounded. There would have been a sharp dip, and then we continue to rise. Irregular random fluctuations. Now these happen in almost every time series chart, and they are fluctuations that we cannot reasonably attribute to systematic changes like trend, cycle, seasonality, outlier, or other structural changes. It's just noise, and we look at ways in future videos at how to reduce this noise so we can make more sense of the data. Alright, now in here we have 3 different plots A, B, and C. Which one has irregular fluctuations? C. C is the most irregular. They're not outliers, they're not really attributed to seasonality, they happen all different times. That is C. An increasing trend? Well, C has irregular fluctuations, but it's also increasing. A decreasing trend, over time, we can imagine drawing a line down through A. A cycle. Now remember, cycle is something that repeats after more than a year. So here we have a peak, or a trough rather, early 2012, there. The timing is slightly longer than a year, so that would be B. Seasonality is repeating within a year. You can see the frequency of A happens more often. It will be A. Alright, that ends our very short preview of time series data. Thank you very much.